Good evening, everybody. Welcome to an interesting Thursday night rabbit hole instead of Wednesday. We did a Tuesday night. We gave us a night between because it does take a lot out of us. So we apologize that if you're normally listening to us on Wednesday, we apologize. We want to keep going, but talking for 3 hours is a lot of work. So welcome to. Uh, the rabbit hole with I'm Joe Slick, and I have my guest, New Brunswick, Canada guy, which who I call Canuck, is my good brother, and appreciate him. Luke is probably taking the evening off. He's been pushing a lot of snow lately, which is great. He's making money because he works hard pushing snow. So when it snows, when he lives way up in the north, so hey, whatever. Over on Twitch, I'll say hello to Eden. I see you, Eden, out there. And Columnist 55 is in the house out there too. And that's pretty much it. Susan and Timmy and yeah, the Snowplow King's probably just listening while he's busting a nut out there, working hard. If he can hear us over his deal. Over on Twitch, for those who do not know, we have a morning report that we put up mostly Monday through Friday, except for on specific days. That sometimes we move it because of conflicts with scheduling, and but to share with you, this is what happens on that. Hi, I'm Joe of the Joe Slick Live Show. My interactive live show is on twitch.tv/Joe Slick Live. Monday through Friday, 7 to 9 a.m. Mountain Standard Time, and occasionally in the evenings at 7. During the live show, I review and talk about reports from government, private, and other reporting agencies and websites regarding celestial and terrestrial phenomena. Topics will include solar flares, sunspots, geomatic storms, and near-Earth asteroids and comets that are being monitored around the world. Included in the report is current events in the last 12 to 24 hours here on Earth, consisting of volcanic, seismic, and weather events. I close the morning report off with what's happening in the local and world news. Thank you, and you can be a part of the morning report by going to twitch.tv/Joe Slick Live. Look forward to seeing you there, and remember, don't get none on you. And you can subscribe, like, and share this over here on YouTube. Share it on Rumble. We're both on both channels of there, so we are. And over here on Twitch, of course, twitch.tv/Joe Slick Live. Rumble is about the same, and I just look up Joe Slick Live, and you'll find him on Rumble, and you'll find it over on YouTube. Appreciate you all for subscribing. If you'd like to leave a gratuity, streamelements.com/Joe Slick Live/tip, or in Twitch, it's !TIP. Thank you for your subscriptions and your gratuities. They help pay for this, and I hate asking for money, so I'm just telling you ahead of time. I appreciate y'all. Tonight, we're going to talk about the Sierra Nevadas, the fault zones of the Sierra Nevadas. And we're going to learn some really interesting things about the origins of some of the faults and what they're capable of doing and what they've done in recent history as we go through step by step and trying to give you a overall view, not a very in-depth view, because this we can take this show here and multiply it by 6 or 8 times and you still wouldn't get it all. It is, there's that much information out there, and we're just trying to glean a little bit and then present it to you to let you say, hey, there's an earthquake out there. Oh yeah, there's an earthquake out there. I wonder why, but whatever. We'll explain kind of the gist of it and why these are earthquakes are important and what they can and cannot lead to, and what they've done in the past and what they could do in the future. But it's not. They don't just happen like, well, there's an earthquake. Why? Kind of explaining why a little bit. All right, at least in part, and according to geology, all right, geological studies and whatever. All right, so without further ado, let's go ahead and share the first one. First page. First, what? I don't want to upload anything. God bless America. Oh my God. Okay, there's screen. God bless. Here's the fall activity. All right. So, oh, grandpa. Hang in there, buddy. Yeah. Share on stream. All right. I'm going to be flying blind here. So if you don't see anything, Canuck, let me know.
Yeah.
Because I'm going to be flying a little bit blind here. But over there on Twitch, they can see it too. All right. So this is a map, a fault activity map of the Sierra Nevadas and all of California, to tell you the truth. Down the bottom of your screen here, I have Garlock Fault. Everything north of Garlock is kind of what we're going to talk about on the eastern side. The top of the western side, which is the last one we talked about, Macamba. We talked about.
We're going to do a little bit of western because that's the first one we're going to talk about, and then come across the valley and start going up on the western.
All right. So we want to finish up on the coastal ranges. I thought we were just going to stay over there, but hey, all right, he's got a plan.
And because we're coming across, but I want to finish this one off first.
All right.
Because I'm focused on like where I have an example of a big quake to use this.
1892?
Yep.
All right.
And it'll be kind of a review of the end of the last episode.
Okay. All right.
Before we start on
if you'd like to see the last episodes, they are in YouTube under the live. Also, they're on Rumble. Look for the Rabbit Hole Joe Slick live. You'll see that. All right. So back over to Vacaville winter's earthquakes. And in the last time we were talking about the three major fault zones. This east of the, or San Andreas part of it, eh? Well, no, it is part of it.
Yeah, they're all considered the same thing, right?
We have the San Andreas on the ocean side. Then in the middle is the what is it, Rogers Creek? Is that it? Macama Fault, and then it goes into the Bartlett Springs. That's kind of where we left off. All the other fault systems, read or watch the last video and you'll catch those. So we're going to stay north of Napa and north of Crater Lake, and we're going
to going a little bit east of Bartlett Springs now.
Okay.
Coming across the valley.
Oh, okay. All right, this one up here. Battle Creek Fault Zone.
Yeah, all those ones.
All right, buddy.
Focus on the one that.
Well, we'll start where you want.
Yeah, so we're just going to read the wiki for 1892.
All right. Really share this tab instead. Here we go. All righty.
It's not super long, so it's not going to take us too long to do.
You can read the top and the tectonic setting. Yeah, go ahead.
Yeah. The 1892 Vacaville, I think is how they say it. Winter's earthquakes occurred in Northern California as a large doublet on April 19th and 21, 1892. Measured on a seismic scale that is based on an isoseismal map, or the events felt area, the 6.4 and 6.2 magnitude events were assigned a maximum Mercalli intensity of 9, violent, and affected the North Bay and Central Valley areas. The total damage was estimated to be between 225,000 and 250,000, and one person was killed. No evidence of fault movement on the surface of the ground was observed as a result of either of the strong shocks, Both occurred in the domain of the San Andreas strike slip system of faults, but their focal mechanism is uncertain. The primary tectonic feature of the region is the strike slip San Andreas system of faults that move laterally alongside one another. From west to east, the Hayward Rogers Creek Fault Zone and the Concord Green Valley Faults are the closest to Vacaville in winters. A 1999 forecast stated that the Hayward and Roger Creek faults have been given a 32% chance of a magnitude 6.7 or greater shock before 2030, and the Concord and Green Valley faults have been assigned a lower probability of 6% each. Vacaville and Winters both lie to the east of these faults along the low foothills. Numerous geoscientists have remarked on the potential for blind thrust earthquakes in this area. These professionals specifically labeled it the Coast Range Sierra Block Boundary Zone. So they're giving it a nice fancy name. In a sequence of published articles from the 1980s and 1990s, and stated that the 1983 Coalinga earthquake, which we talked about in another episode, occurred within this zone. So they're saying this Coast Range Sierra Block thing.
Within this blind thrust zone. Now, let me just make sure people understand what blind thrust is here. Come on, enter. A blind thrust is a thrust fault that does not break all the way through the surface, so it's not visible on the ground. Blind thrust faults are difficult to detect until they rupture because there's no surface evidence. They can cause uplift when they break, but they don't create clear surface ruptures. And here's examples of the thrust faults in Los Angeles. We talked about all these: the Elysian Park thrust fault, the Northridge thrust fault, the Wilmington blind thrust, the Puente Hills blind thrust. We talked a lot about these in the previous videos. And this is the clearest image that I can share. This tab in here. The blind thrust is one that's down here. You see, this is the thrust fault right down here. You can see how it rolls over, the ductile, it rolls over. And this is how the ocean comes up and it just as the land rises up out of the sea, that's what we get. And usually there's some pushback from one side and the other side. These are all compressional type of faults. And let me see if this one has it here. Detached fold fault propagation. Yeah, you'll see. That's what we're talking about, like this. The blind thrust is like way down here. Okay, so back to share this.
We're going to read the earthquake section.
Okay, go ahead.
Yeah, each large shock in the doublet, one on April 19th and the other 2 days later on April 21, had a high intensity and was felt over roughly the same geographical area. The area over which the initial shock was felt, with an intensity of 8, severe, was about 1,100 square kilometers. And the area for the second shock was about 890 square kilometers. The farthest extent that they were felt was from Redding in the north to Salinas and Fresno in the south, and to Virginia City, Nevada in the east.
That's a pretty big area.
So that's pretty crazy.
Well, it was a 9 maximum intensity, so that's pretty good. A 6.4 to 6.4, somewhere in there. So yeah, pretty.
And this is going to be important when we talk about the other ones tonight, because
right.
They're all like the same belt area or whatever. So, but anyway, investigators completed a study of the area that included a 3-dimensional crustal velocity model. Proprietary seismic reflection data were also inspected in an attempt to establish a source for the sequence. Observations of the range front and modeling of strong ground motions led to a presentation of a 17-kilometer, 11-mile rupture on the west dipping Gordon Valley blind thrust fault that could have produced the fault intensities that were specific to the April 19th event. damage. The shocks affected Solano and Yolo counties along the border of the Sacramento Valley. In the north, the communities of Esparto and Capay both experienced Mercalli intensities of 8 severe.
Pretty strong.
Yeah, which is associated with damage. And in the south, Vacaville and Fairfield both experienced the same. Work by seismologist Toussaint Topazada, that's quite the name, that was published in the 1981 report further clarified that Vacaville was at the center of the destruction. Damage also occurred at Dixon as well as the area of the highest reported intensity of 9 violent midway between Winters and Vacaville at Allendale. There, some buildings were damaged, some collapsed, and a 1.6 kilometer, 1 mile long ground fissure were observed. These widespread and north trending cracks were very narrow, from 2.5 to 7.6 centimeters, 1 to 3 inches in width. Despite these surface cracks and other offset drainages and other lineaments, no surface faulting occurred. This was confirmed by trench excavations where these features were found. Other ground effects occurred, though. Reports of rock slides and dislodged boulders were written about in the newspapers, but the most common type of damage were the many chimneys that were damaged or destroyed. Total damage was estimated between 225,000 and 250,000, and 1 person was reported dead. So then the intensity, an isoseismal map for the April 19th event shows an asymmetrical and slightly elongated pattern of isoseismal lines of equal intensity on the north-south axis. There are high intensities east of the Napa-Solano County border. No locations in Napa County reached any higher intensity than 6, indicating that the shock originated east of the Vaca Mountains, or Baca Mountains, however they say it.
It's Vaca.
The April 21 event differed slightly in that the strongest effects were shifted to the northwest. So now what we're going to do.
So there were 2 quakes in here that we're talking about. April 19th of 1892.
Yeah.
No.
21.
And then April 21 of 1892. Also, there was 1892 of 419 and 421. Oh, it's the same. Why are they doing that? That's weird. All right, so we're in 1892, everybody, not anytime recent, but yeah. But this is all prior to the big quake of the 1906. This is straight up from that. So you want to go into the next?
Yeah, so we're going to do the Gia thing to see where it came from again.
Okay, let's go to the Gia thing. 1892. 92. All right. Share this tab. Here we go. I'm zooming down to 1892. This is kind of like the world, history of all earthquakes.
Yeah.
1891, 1892, Tasman Sea, United States, 1892, 214. Oh.
Yep. So that February 14th one
was just south of the border.
Yeah, the 1892 Laguna Salada quake, which is basically the same place as the 2010 one. And it was the same thing, like I said.
Yeah, it's 7.2, yes.
So that was like
Imperial Valley.
Yeah. So it's crazy. So that one there is pretty obvious. And if you look back into 91, there was a big quake in El Salvador. And then go back into 1890 and 18.
I got the wrong date here. This is February 24, 1892. Okay, the Imperial Valley. Yeah. You got going in 91, Casamagua, 1891. Is that what you're talking about?
Yeah, in 1890, there was a whole bunch of Mexico quakes.
All right, so
and going back 1890 and 1889.
Salvador had a 7.1, 7.2. Now remember, they don't have the measurements back then. But this is an estimate based on what they've seen. So it could be a little stronger, it could be a little weaker, but it's roughly the same as the 1892 quake. That's interesting. And it's the same as the Imperial Valley quake. Okay. I don't know where the Sudokan is. That's 93 anyway. Indonesia, Guam, Philippines, US. You know what's funny? They don't have it even on here, do they? The 1892 Vacaville quake. Yeah, it's not even on here.
No, they don't have it on there because I guess to them it wasn't big enough.
Wasn't strong enough. Yeah, but obviously did kill a person.
Yeah.
And that's why we always look.
Yeah. So when I first started studying this one, I said, well, the first thing I thought of was, well, that's like less than 2 months after the Laguna Salada quake, because I'd already studied 1892 and we talked about it before.
Right. We talk about that a lot. Yeah.
Yeah. So that's what was going on. So this happened not very long after that 1892 Laguna Salada quake.
So again, what we're talking about for those listeners who can't see the screen or don't know what we're talking about, what in a lot of the data that's out there that you can visit, they won't show anything below a 7 or below a 6.7. And Laguna Salada was a 7.2, but that was in Mexico. And so a lot of times they won't think that they're related. But what our supposition is that
they've always been related.
Yeah, that follows a kind of a pattern, a persistent pattern that led up to the 1906 quake, and what we're way back in 1892 now. But you're seeing a huge quake happen in Laguna Salada. We're seeing one down in Salvador down there, but also up in Vacaville, which is north of San Francisco, right? Yeah. And we also saw, which they believe the source or the center of the 1906 quake is like right in this area on the screen, which is basically Monterey Bay, in the mountains of Monterey Bay, or the Sierra Azul open space preserve somewhere out in Gilroy, what is it? Sandcat, Malchin Juan. Well, I can't even read it. Temple Reservation. Okay. And then we talked about another quake just north of it that happened. And then bang, both of those happened in a relatively short time in that same time period. And then we get more quakes that happened further north in the Santa Cruz Mountains. And then now we got a quake north of San Francisco. I don't know where Vacaville is, tell you the truth. Where the hell is Vacaville? I don't think it's that far. No. It's north of Nampa, right?
Yeah. Coming across.
Okay. Yeah, I don't even know where, dude.
I think it's a hot road.
I got it. Yeah, Nacoville is just outside here. In share this tab. Vacaville's right here, right? These mountain ranges. And here's the San Andreas right here. This is the big monster. Vacaville's out here, somewhere out there in these mountains, right? Antioch is south of us. And then like Berricia or whatever, right? That's up in here. We got Napa's out here. There's the Rogers Creek. Here's the Concord Fault. Here's the Marshall Creek and the Greenville Fault Zone, right? All these three lead up into this mess, which we talked about before. which then splits off into the Bartlett Springs and then also some springs off in the Macama Fault um, that are going north. But all this crunching of whatever is because there's a lot of water right here and the ground moves quicker, I think. But hey, just me, all right. Um, but
Yeah, but it's
Vacaville being out
still
here,
like northwest to southeast faults, basically.
yeah, it's a lot of soft sediment. That's what I'm saying, and it's the ground is not very thick. The crust is not very thick. It's saturated with water, so it's easy for the slips to happen. Um, but they need a push. And our supposition is that it pushed all the way up the coast and popped up here. Wherever it's weakest is where it's going to give. All right. And the weakness itself could mean that there's something called Coulomb stress, where it's a buildup of stress that's being pushed. And then when it can release itself or when it breaks free of something, it moves forward. And also, the North America is coming over, almost due south right here anyway. Almost due south, and the Pacific plates, north northwest. Both are grinding up on each other, like whatever. I'm not going to say anymore, but yeah, Vacaville's right here, north of downtown San Francisco, northeast, going towards Sacramento. By the way,
Yeah.
so that's kind of the geology. That's why we're talking about this a bit. But
So now what we're going to do next is go across the valley and start going up the foothills.
okay, now we're going to talk about the foothills.
Yeah. So
All right.
the next one's a map.
All right. Yeah, I don't know. See if I can get that map, eh? Open a new page. All right. Yeah, this is a map. Bear Mountain Fault. What other fault is this? Mellon's Fault.
Yep.
All right. Yubo River. Oroville right there. Oroville River.
We're going to focus in on the Oroville one.
But here's Lake Tahoe right here. So what we're talking about again in this one, we're going to be right up in here, north of Sacramento.
Yeah, a lot of these names of these faults I recognize because they're all the same places there's been wildfires. Slate
right.
Creek, Spencerville. Well,
Right.
there's been fires around Oroville a couple times because it's all Butte County. Right.
Right. Here's Oroville right here. All right. There's a quake here in 1975. We'll have to look into that.
Yeah, that's the one we're going to do.
Okay. So we're talking about here the Paynes Peak Fault Zone, Cleveland Hill Fault Zone, Swan Ravine Fault, Prairie River Fault, Spencerville, all come into the Monocline Fault, the Cohasset Fault, Ridge Fault, Chico Monocline, sorry, and then the what is it? The Corning Fault goes right up the middle, and then there's Battle Creek, which crosses over. It's an east-west fault. Interesting, like the Garlock Fault, east to west. Yeah, there's another one up north here.
Yeah,
and yes, it has the same kind of play. It cuts across. There's a junction that moves up north northwest, and there's a junction that moves south southeast, right through Lassen.
Well, the west ones are probably where there's the mountain passes too, because it would be like a crack right on through. So probably a lot more than.
So we were talking about right here at Vacaville, right here. Okay, now we're talking just north over on this side.
Yeah. So we're going across. There's a method to my madness.
Sure, there is, buddy.
So now we're going to talk about the 1975 Oroville quake.
All right.
It's quite the story.
All right. So you want me to read the abstract 1960 first? Or is that just the map?
That's just the map. So we're going to do a wiki on 1975 Oroville quake now, and then go into more detail after that.
All right. 1975 Oroville quake. All right. And share this tab. All right. So in 1975, the Oroville quake occurred on August 1st, 1975 in California. Not 18, but 19, okay? And had a magnitude of 5.9. It's one of two earthquakes in the Western Hemisphere which were predicted.
Yeah.
The epicenter of the quake was about 8 kilometers or 5 miles southwest of the town of Oroville, California, at a depth of about 5 kilometers or 3.1 miles below the Oroville Dam, and the lake created as a result of the dam's construction. The earthquake was predicted within a few hours, warning following an unusual sequence of smaller earthquakes, which in retrospect turned out to be foreshocks. Following the experience gained from the formation of artificial lakes behind a large dam, such as the Hoover Dam, Nevada, and the Alfada, Algeria, the ORV seismic station was established to closely monitor induced earthquakes, should they occur. This induced seismicity is the result of load exerted by water column on the upper part of the crust. This load breaks the balance that exists between formation of the lake, renewing the activity of ancient and inactive faults, and or activating planes of weaknesses in the rocks. These are usually low magnitude earthquakes. The water mass in Oroville Reservoir was about 4.3 billion cubic meters of water. Not only the load itself causes the induced earthquake, rocks contain a little amount of water in their pores. In these sometimes microscopic holes, many minerals exist as more water enters the rock. The pore pressure inside increases, slightly increasing the distances between the mineral components. However, the rocks are crossed by an inactive dormant fault. The increase in pore pressure reduces the friction along the fault and may allow an earthquake to occur. Pore pressure refers to the pressure of groundwater held within a soil or rock in gaps between particles or pores. Pore water pressure below the phreatic level of the groundwater are measured with piezometers. Yeah. The vertical pore water pressure is distribution in aquifers can generally be assumed. Hold on. I'm going to go to that open link here. This is really key. This is key. You got to key in on this because this is what they often talk about. Okay. The vertical pore water pressure distribution in aquifers can generally be assumed to be close to hydrostatic. Hydrostatic is the branch of fluid mechanics that studies fluid at a hydrostatic equilibrium and the pressure in the fluid or exerted by a fluid on an immersed body. In the unsaturated Vodos zone, wow, another word. The Vodos zone is also termed the unsaturated zone in the part of the earth between the land surface and the top of a phreatic zone. The position at which the groundwater is at atmospheric pressure. Hence, the Vodos zone extends from the top of the ground surface to the water table. Okay. Out there, eh? But all these definitions will help you. The more you hear it, the more you'll understand it. That's why we're trying to do this too, trying to bring each of these definitions to fruition for you. The pore pressure is determined by the capillarity, right? And is also referred to as tension or suction or matrix pressure. Pore water pressure under the unsaturated conditions are measured with tensiometers, which operate by allowing the pore water to come into an equilibrium with the reference pressure indicator through a permeable ceramic cup placed it in contact with the soil. Pore water pressure is vital in calculating the stress state in the ground soil mechanics from Terzga's expression for the effective stress of soil. The effective stress can be defined by the stress depending on the applied tension and the pore pressure, which controls the strain or strength behavior of soil and rock for whatever pore pressure value, or in other terms, the stress which is applied over a dry, porous body provides. All right. So there you have it all. That's what pore pressure is. And so, how does that relate to what we're talking about in the Oroville Dam?
Well, we're going to read more about this, and then I'm going to explain it.
Yeah.
So we're going to say after Lake Oroville formed and reached its maximum volume in July 1969, so it was at its full thing.
Capacity.
Yeah, in 1969, no earthquakes occurred for nearly 6 years until a magnitude 3.5 earthquake occurred on June 28th, 1975. In the following month, about 20 more earthquakes were recorded, and on August 1st, 1975, a magnitude 4.7 earthquake occurred, and shortly after that, the main earthquake of magnitude 5.7 was felt in a large part of Northern California and in part of Nevada. So same as the
Yeah.
1892 quake. So see, that's what I start questioning all this. The dam was not damaged, but minor damage was caused to buildings in the town of Orville. It is unclear why, for 6 years after the completion of the formation of the lake in its full volume, there was seismic silence. A possible hypothesis is that because during the winter of 1974-75, large amounts of water were released from the lake to make room for the snowmelt in the spring. The rapid filling of the snowmelt water caused a major change in the hydrostatic pressure that may have caused some dormant fault south of the lake to reactivate. Now, in the newest stuff, they call this dormant fault south of the lake, they call it the Oroville Fault. So they named it after the town and the lake.
Yeah.
And it's
What?
another one that's foothill faults,
Right.
part of the foothill fault zone. So on that map I showed before,
Mm-hmm.
it's called LOW on that Lake Oroville
Right.
window. They called it back then when that map was made, but it's basically the Lake Oroville fault.
Right.
So I
What's
thought that was funny.
what's also in the area of Oroville, which is up in the north here. Um, Dub Diesel is saying that there are also oil drilling south of Vacaville, and the Chevron has a huge facility south of there. It sits on the edge of the fault, just south of Fairfield, and lots of fires also due to the PNG and the power lines. I agree with all that what he's saying there.
Yeah.
So, in looking at Oroville here, where the heck am I? Oh, wait, on this side. All right.
Just find the dam.
Yeah,
It's
here's
been
Oroville.
recently, but
So, in this section down here, you know, it's full of oil drilling. Now, if you don't know California, never been to California, the whole state is permeable because it's been stuck so many times like a pincushion all throughout the Sacramento Valley or the San Joaquin Valley. Just incredibly in the south. There's millions of them. You see all these farms down the central part of it, and then all of a sudden there's an oil rig. Well, shoot, there's another one, and shoot, there's another one. It's full. So and as Dub Diesel and I were discussing there, as you were reading, um, what happens when they pull oil out? Well, same thing when they pull water out. there's subsidence that happens and faulting occurs, adding to the stress. And or if they don't pump something in there that's the same thickness of oil, then the pore pressure is going to change. And very well could have been part of all that stuff. But anyway, so back to what your 19.
So the next thing we're going to do is see what was going on quake-wise.
Okay. All right.
All over.
All right. So we're talking what month here in the quakes?
That was August 1st.
August 1st. All right. So in 1975, we're going to look outside of the United States as well, just along the Pacific Rim. Columbia popped in January with a 6.5.
Yeah.
Near Islands, Alaska. We've had those before, 7.6. The Adriatic Islands, we've had 6.5. Chile, Coquimbo, 6.9. Peru, which is north of Chile, 6.2. Idaho pops with a 6.1. There's your internal. I wonder what was happening out there in the Atlantic.
You'll find out here. Just keep going.
Venezuela, which is on the Atlantic side of South America, 6.1. It didn't say where. Mexico, Guerrero, which is on the Pacific side, 6.2. Now we're into May. Chile, Bio region, way in the south, is 7.7. And get this, a 7.9. Wow.
It'll show you where it is if you click the 1975 North Atlantic earthquake there.
All right. Oh my gosh. That's not good. Oh, wow. So the epicenter here. See what do epicenter. Looking out the wiki. Okay, it's offshore Portugal. Not over to the it's not Maldives. It's what are those islands called in the center part?
Azores.
Yeah, between the Azores and Portugal. Not good. That's a huge quake right there. Wow. Now that's on the eastern side of the mid-Atlantic ridge, but still a 7.9.
If you follow it across, it goes to Mendocino.
Is it at the same latitude?
Yeah, because Azores lines up with everything in Virginia, then going right across, it lines up with Mendocino.
Oh, it's very, very, very close. I got. Let me look at here.
We've seen this before because we've seen the other Greece component.
Show grids.
Italy component.
All right. So the Mendocino's at 40 degrees, or a little bit above 40, to tell you the truth. And we're going all the way over to the Azores. Well, looky there, everybody. Azores just a little bit south of 40, and they're at 38. I mean, they go from 40 all the way down to 37, and that's the ridge right there. And this quake that he's talking about, whoop, not this one, not that one. This one, yeah. 1975. Does it give me an epicenter? It does. Open. Oh, poop.
Didn't work. Didn't
copy it. All right. Maybe it will open up this time here. Looking for the wait, that's Google Earth. Boy, they don't make it fun. Not found. How about just give me the URL? All right, here. There we go. All right. So I'm going to look this up. Boom, boom, boom. Paste. I have to get rid of the comma. All right. So this one's at 36 north. So just 4 degrees south of 40.
Yeah.
So, and that's not good because that's in an area where 1755 happened.
Yep. Same area, basically.
Yeah. Wow.
Just a little bit farther out.
And that was 6.9 in 1975?
Yeah, that was the biggest quake that year, 7.9, I think.
7.9.
Yeah.
Yeah, because almost 8.
Yeah, because I think 1755 is 8.6 at least.
Yeah. Well, there's 2 earthquakes, at least 8s. Yeah. Yeah. All right. Which is all suspect anyway. Crazy.
So it's interesting that this Oroville quake happened the same time as this.
Right. So back to the Kia.
Yeah, we have more stuff to look at still in there.
Okay. And North Atlantic?
Yeah, because we left off with North Atlantic, but we still got to get to August.
This was the interplate location 200 south of Gloria Fault. Presumed boundary between the African plate and the Eurasian plate. Had a right lateral strike slip volcanism. And the oceanic strike slip damage reported in Madeira. 250 kilometers away, a tsunami of 3.3 meters. In Lagos, Portugal. 6 feet.
Madeira Island is just the one above La Palma.
6 feet in Ponta Delgada in the Azores. So good tsunami.
Yeah.
All right. So,
well, there's a big tsunami.
We're going to continue. Yeah, we're going to continue in the wiki here, in the list of quakes. Still in June, Kuril Islands went 8 turd, bunch of them, and then Yellowstone, 5.9 in Yellowstone.
Well, to me that makes sense if the North Atlantic is being pushed by is pushing North America 7.9.
Yeah,
all this stuff should adjust right across.
Yeah, that wave come right across, doesn't it?
Yeah.
Interesting, and a depth of 7. That's really shallow too. Yeah. Wow, that's really shallow. How deep was the 33? Yeah. Wow. Okay. Straight across. So I'm going to find out where Yellowstone is here. What Yellowstone is right here. And it's roughly at what level is this one? 44, 45. So 44, 4 degrees north. Not even that. Yeah, 44 degrees, 30 minutes north. So, yeah, just north of the Mendocino on the Blanco fracture. And another one just south of the Mendocino. Wow, that's a volcano right there, boy. You can see that. I never saw that before. Really getting clear. Interesting. So, continuing in July, Gulf of California popped with a 6.5. That stands for reality. Papua was going 8. In August, Northern Cal with a 5.7.
That's the one we're talking
about. Right. Then Argentina popped right after the 6.2. The Commander Islands. Why does the Commander Islands come up again? That's at the very end of the chain of the of islands coming out of Alaska all the way over to Kamchatka.
Yeah. Well, that makes sense because the curls were all going wacko.
Yeah.
So it started adjusting.
So the curls were adjusting. The Mexico or in Baja California is adjusting, and yeah, that pressure. Interesting. Where here they drew a line from here over to here. The commanders are right there. So that quake happened here, and it popped all the way over to here, and then in Kamchatka as well. Oh, that's kind of interesting. We often see earthquakes happening in the Atlantic. Iceland, which is right here in between. I wonder if there was Katla going off at this time?
I don't know. We'd have to look, see what was going on in Iceland in 75. Because I don't remember right offhand. But I want you to keep going down because there's another interesting one.
I got you. Well, I think Hawaii was around then too. All right, continuing. So Wyoming popped with a 5.9. Gulf of Cali popped again with a 6.5. Miramar, British Columbia, Northern Cal, the 5.7 with, that's one we're looking at. All right, September. Nothing in. Nothing. Sometimes I have to read them, the names, because I'll lose it. Chile, Antofagasta, 6.3. And then November, Hawaii. Didn't I just say Hawaii? Boom.
That's the one I wanted to get to because that's the second biggest one since 1868 at Hawaii.
Right. I think Hawaii too. That makes sense.
So the whole center part,
baby.
The whole center part was going across.
Yeah.
Going crazy.
That's, and share this tab here. So basically, this 7.9 right here on the right-hand side of the North Atlantic side, right, pushed the plate, the North American plate from the Eurasian plate, right? There's also a split between the two, right in this region from Gibraltar out here till the Azores. There just is, and it goes all the way across to Nova Scotia, and that burst, if you follow that thing, goes all the way to Yellowstone. Yellowstone's up here, so it moved, and then over here it pumped right here where the Commander Islands are. It blew up Kamchatka, came back down the chain down here to a 7.7 in Hawaii. Now, there were earthquakes in the Philippines and over here in PNG. There were some down here at Fiji, and I think it was in Samoa too. Where are we at? Right here. The Philippines popped. A bunch in the Philippines. Some of that quake moved from Kamchatka out into Afghanistan and all that, so it went north. We had a 6.7 in Turkey. Philippines really banged hard quite a bit. Papua. There's the Papuas. But where's that? Where the North Atlantic was up here. Gulf of California, Miramar banged out. Um, Yellowstone, and then the Kurils. There's the North Atlantic right there. That's pretty significant. I always look to the North Atlantic for as an instigator in major quakes in the India side as well as the North American side. However, this being part of the Eurasian plate where it broke, you can see how much it just really pushed through the Orient. You actually even could have come across, you know, we have this quake here. This is where our quake is. We just, followed it across. And you can see there's Tajikistan, right? I don't know what happened in Japan. I know something happened in Taiwan, but Honolulu's down here. But, well. Are we talking in 1975?
Yep.
Yeah, that pushed the Mendocino plate. Yeah, it pushed the Mendocino. That earthquake on the other side of the planet pushed the Mendocino. This one here. Not only did it break in pressure this side, but it pushed the Mendocino into North America. That's wild, dude.
Yeah.
And is that what you were trying to get to?
Yeah, basically.
All right. Yeah,
and the felt reports on that were almost identical to the other ones we've been talking about. So why? Well, we're going to see because now we're crossing the Sierras to the big bad boy.
Right here. And then it goes all the way down into December, Peru, Papua New Guinea, Western Samoa. A 7.8 Western Samoa. That would just devastate. Shoot, there's Greece again.
Yeah.
At the end of the year.
It's crazy.
What happened in 74? What led up to this? Let me just real quick. I'm just going to zoom through. Because August is our target date. January. Antofagasta 6.4, Peru 6.3, Mexico Michoacan 6.1, Alaska 6.5, Costa Rica. There's your Costa Rica 6.2. Remember what we're talking about? Vacaville, right?
Orville.
Not Orville. Yeah, Orville, which is in the north of Vacaville.
Yeah.
Colombia 5.0. Kurils 6.1, Peru 6.0, Gulf of California 6.3, Venezuela 6.1, Bolivia 5.9, Panama 7.3. Oof. That's a key player right there.
Yeah. So Central America going nuts.
Yeah.
Add in the North Atlantic.
Chile had a 7.1, yeah. I don't really look to Chile pushing too far north, but I haven't quite figured that one out. But definitely Peru, Ecuador, Panama, Costa Rica, Salvador, Nicaragua, Mexico. We're seeing all those. There's a Peru 7.6. They just said that.
Yeah.
November. Peru, Lima again, 7.2.
So it came up.
Yeah.
Basically.
It looks like it.
That's what it does.
Peru again, 6.0. There's Guatemala, 6.1. All right. So it went from a 7.2 down to a 6.1, pushing some 1,500 miles. And then as it went into 75. What let's see, in January, because we're only going to August. Columbia 6.5 from 7.2 to 6.5, right? Alaska 7.6, Andreanum Island 6.5. It's way out there at the other end of what's going on. The Chile at 6.9, way in the south. Laredo 6.2, and then Idaho 6.1. We've noticed a pattern persist that depending on the location of it, Peru, sometimes it goes up along the Rockies, and sometimes it'll go up, the Nevada side, and then other times it'll go up the coast. We've noticed it kind of three different locations. Valenzuela, it's kind of interior, right? So Valenzuela, so Idaho and Valenzuela, right? And then Guerrero, Mexico, that's filling in the blank. Chile went way down there, and that's when the North Atlantic popped. Wow. Idaho and get this, Idaho and 7 depth Yellowstone. So yeah. Okay. All right. So we're moving on.
Yep. So next one, we're jumping across the Sierra Nevadas to everybody's favorite, Long Valley.
Long Valley. Okay.
Yeah.
So we're going on the opposite side of the Sierra Nevadas now, everybody. Yeah. So we're leaving Oroville, and now we're going down here to Long Valley.
Yeah.
Right here. Okay.
So this map is the super simplified version, because it even says that.
Right.
Showing the major faults in Long Valley caldera. Well, the faults it has on there, the ones in red, are what they call the Hilton Creek Fault Zone.
Okay.
So we're going to go into this in more detail with the next stuff. So there's a reason why I picked this map.
All righty.
So this fault zone, basically, if you follow it down, it starts where Mammoth is and comes up into the middle of the Long Valley caldera. So you need to remember that for when we do the next link.
All right.
Which is the 1980 Mammoth Lakes earthquakes.
Okay. This one here, 1980 Mammoth earthquake. Now, you know what happened in Mammoth, 1980, right, everybody? A little volcano up in Seattle area exploded. Yeah. And this is in 1980, the same time period. So he's going to show us something that it's interesting about the Sierra Nevada fault zones of earthquakes, okay? Or Sierra Nevada or faults, all right, so go right ahead, 1980.
Okay, so I'm going to read it. The 1980 Mammoth Lakes earthquakes, because there's way more than one, affected Eastern California, with the sequence largest shock occurring on May 25th and measuring magnitude 6.2. But there's 3 other 6s besides this one. The main shock and its strong aftershocks, located near the Yosemite National Park area, were felt in parts of California and Nevada. So here we go again. 9 people were injured, and there was significant damage in Mammoth Lakes. Okay, the source fault was identified as the Hilton Creek Fault, a northwest-southeast striking normal fault straddling the eastern foothills of the Sierra Nevada. The structure is considered geologically young and is one of the master faults of the Sierra Nevada rangefront. So now we're on the eastern side of the Sierras. And that from the picture in the map, it goes right through the middle of the Long Valley caldera, which I thought was interesting. I started looking into it. Now, the impact and aftermath. There were 9 injuries associated with rock falls, including at least 2 reported in Yosemite National Park. Damage in Mammoth Lakes was considered the worst, with collapsed chimneys, ruptured water pipes, and cracked plasters and windows. A surface rupture propagated beneath and damaged the town's elementary school considerably. 80 people had to be rescued on Mammoth Mountain after power outages affected ski lifts and gondolas.
Remember that they were stuck up there. Yeah.
Yeah. The additional shock on May 27 injured another 4 people, and similar to the shocks of May 25th, was accompanied by landslides and rock falls in Yosemite National Park.
Mm-hmm.
Officials of Mono County designated the region a local disaster zone. Some of the injured were hospitalized at Mammoth Lakes.
Oh, get this. We just lost connection with Twitch. Continue.
Okay.
The
shocks which occurred on Memorial Day forced leisure activities in the area to cease. Visitors of Mammoth Lakes also began evacuating the town, causing congestion along the main road. At Convict Lake, over 150 visitors across 92 campsites fled the area. Some trails in the area may have been buried under 30 meters of debris from landslides. Rescue helicopters.
30 meters? Are you kidding me? 30 meters? That's
so
90 feet, right?
So a lot of stuff must have moved. The landslide. Well, I suppose if they had 4 6s, that would make sense. Because that's what it was when you look up the actual mags. Yeah. Rescue helicopters were also deployed to look for people potentially trapped by avalanches and rock slides. So it's wild.
Memorial Day forced leisure activities as areas to cease.
And what's interesting about this, these 4 6s happened basically 2 weeks after Mount St. Helens. But of course, nothing related.
Yeah, Convict Lake, over 150 visitors across 92 campsites fled the area. Some trails in the area may have been buried under 30 meters or 98 foot of debris from landslides. I don't know if anybody died in there, but rescue helicopters were also deployed to look for people potentially trapped by avalanches and rock slides. That's crazy, man. Yep. I remember when they were searching for people got trapped.
And they were kind of worried that Long Valley was going to erupt because Mount St. Helens had just blown up 2 weeks before, so they were freaking out back then.
Well, yeah. Oh, I have a thought about that anyway. I think they're all connected.
Yeah.
Just me. That's why it's interesting how you got Mount St. Helens blowing up with a 5.6, and then it lost its face. Boom. And it's the most active volcano of all the Cascades. Yeah. And then all of a sudden we get 3 6s up and around, this area. Now, Yellowstone is not in that area. Yellowstone's adjacent to it. Here's the Yosemite. Sorry, Yosemite's. And let me share this in here. So here's where the earthquakes were happening, or actually they were happening right here, Yosemite, right here, but it was felt over here, straight across. Okay, that isn't too far. Probably 40, 50 miles.
Yep.
But a long drive.
What we're going to do next is look up what else was happening in 1980.
All right.
Wait till you see the first one.
Oh, okay. Looking at 1980. See, I don't look this stuff up because I liked the surprise, and he always surprises me with things like this. Portugal's Azores, 6.7. Does that sound familiar, anybody?
Come on now. There's a reason why I picked these quakes, but they all seem to work out whenever I do it.
And you know, Livermore earthquake, 1980, 5.8, right? People injured, damage that reached 11.5 million rate. The Lawrence Livermore National Laboratory, in particular, was impacted by the shaking in January. February. Here we got Papua going again, but Loyalty Islands. Fox Islands, 6.9. Yeah, and okay, nothing there. There's an Italy one. Guatemala, 5.3. So remember, prior to anything happened in 1980, right? The Azores popped with a 6.7, right? We can go back to 79. Let's go back real quick.
Yeah, just to see.
Just to see, you know. And share this tab instead. All right. The list of earthquakes in 79. Okay. Let's start with January. Guerrero, Mexico, 6.6. Alaska did a 6. February, Alaska did a 6.7. Peru did a 6.9. Around Reguipa, I don't know, sixth largest department. I don't know where that is. Alaska. Yeah, Arequipa. Alaska had a 7.1. St. Elias earthquake, they call it, 1979. Had a 6.7, a 7.1, and a 6.0. It started with a 6, and it progressively got insane. Mexico Guerrero came in with a 7.6. I think we already had one. Yeah, 6.6 was a Soviets did a nuclear test out in Kazakhstan. Okay. 7.6 in March. The DR, which is what? Yeah, that's it. You know, Caribbean. You know, 6.1. Caribbean, right? And then Chile, Atacama, down south. Okay. I haven't brought that. Alaska, another 6.4. Peru had a 6. Then Oaxaca, 6.3. Panama, Panama, 6.5. Strong quakes, everybody. Northern Cal, 5.8. Coyote Lake. Yeah, we didn't talk about that one yet.
No.
Calaveras Fault near Lake Santa Clara County.
Yeah.
All right.
So that's one that was under 6, so they don't focus on it.
Because it's just south of San Francisco.
Yeah.
Costa Rica, 6.4. And September. Umbria, Italy. It's in the middle of Italy, which is very bad for that.
Livermore and San Fran area acting up too before.
Yeah. Guatemala popped with a 5. Mexico, Baja California, 6.4. Guatemala again, 6.8 and a 6.6 in October. November, Greece, 5.4. Colombia, 6.4. December. Ecuador, 8.2. The 1970 Tumuca earthquake, 8.2. This is all prior to St. Helens now. Okay. And 8.2. Where was the other one? Guatemala, 6.8, 6.6. Mexico, 6.4. Guatemala, 5. All before Costa Rica, 6.4. Northern Cal, 5.8. Right? Panama, 6.5. Everything moving up. 6.3 in Oaxaca. Alaska had popping with 6.4. And the DR, there's the DR in the Caribbean, right? And here's Guerrero with a 7.6. So a ton of stuff happening in and around the Caribbean plate and just south of Peru, with Peru popped with a 6.9, and Guerrero with a 6.8. So all that stuff's happening prior to it. So as we go into October, Guatemala did a 5, Baja did a 6.4, Guatemala, Central California, Central America, 6.8, 6.6, and then November, Colombia with a 6.4, and then December, Ecuador, which is just next to the Galapagos Islands, right? It's next to Colombia on the western side. It's on the Nazca Cocos plate boundary. It just banged with an 8.2, right? And then as we go into 1980, January, Central California, the Livermore earthquake, right? Where the hell was that one? Livermore. Hilly area, Mount Diablo. So that's San Francisco. Okay. So San Francisco's banging. Baja's banging. Mexico's banging. Costa Rica's banging. Ecuador banging. Peru banging. February. And I don't know what day the other one went. Fox Islands had a 6.9. That's up in Alaska. So it went all the way up to Alaska. And then Guatemala bangs with a 5.3. Then St. Helens unloads with a 5.7. Then Long Valley starts to kick off with a 6.1, 6.0, 6.1, 6.2. No joke. Baja California comes back the next month with a 6.3. Then July comes, and there's Greece in the middle again. Crazy going Greece. I don't know what. Then in Argentina, 6.1. Then Kentucky, the largest in its history, pops with a 5. Then August, Guatemala 6.4. Ecuador again 5.6. September, nada. October. Central Mexico. I think Puebla is along the Mexico City comprised of federal. Anyway, 6.4. Central Mexico. November, off the coast of Northern California, the Eureka quake, 7.2, caused $2 million damage, and we've talked about this one. Peru, 4.9, Colombia, 5. And in December, Vancouver Island, 6.8. Bang. I got to look at 81, man. Come on. Shoot, howdy. I'm loving this. Rat Islands came in with a 7 in January. February, Greece is saying hello to all of us all the way through the next month, too. 6.2 in March and in Chile. So it's way south. Peru came in with a 5.3. And what happened in Southern Cal? In Southern Cal, Westmoreland, 1981, a 5.8. Do you think it's still moving? Oh, yeah. Ecuador, after it had that 8, a 6.4 in May.
Yeah.
As Greece still says hello. Peru, 5.2. Here's July. Coming in July, nothing there. August, nothing. September, got quiet. But not anywhere. The Kurils were at 6.6. 7.7 in Samoa. Tsunami was observed, which swept ashore some of the islands. 1 person drowned. Yeah.
Does it remember in the previous one we looked up, there was a
Samoa. Yes, sir. I keyed on that because I do like the Samoan people. I think they're wonderful.
Yeah.
October. Yeah. Colombia again, 5.4. Mexico Guerrero, 7.3. And it's not done, everybody. And some, do these things keep repeating themselves? It appears. But you've got to look beyond, you have to look beyond the week before and the week after.
It's
And
the
we're only
system.
looking 1 year before and 1 year after. And we're seeing that with the large quakes. Now, you can still say this about the smaller quakes. It still happens. I can start to see patterns. Say, hey, yeah, I want to hear it. Like, what is it? I thought about one the other day and I said something to somebody. Sure enough, there was an earthquake in California, Southern California. Why? Because you start to recognize the way the plate boundaries and the way the shift is working. So bang, 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 bang. Hey, wait, okay. It's gotta hit here. We don't know what much. We don't exactly know where either. But it's gonna hit it. And if everybody's popping at sevens, you can bet California's gonna get a 5 and maybe a 6. But if everything's popping at, 6s and 5s, California's gonna get a 3 to a 4. But see, and if everything starts popping at 4s and 5s, California's going to get a 2. And people don't see that. They don't see the repetitive motion of the plates. The plates bang each other, and there's a certain kind of method.
And they all adjust.
And everything adjusts. Yeah.
So the bigger the quake, it causes large-scale adjustments.
Right.
With all the other ones that it's running into.
Right. And we can see when something happens in the mid-Atlantic ridge that's large, we can see it propagate clear across North America. We can see it prop into South America. We can see it prop through the Caribbean plate, and we can see it pop into Alaska and over into Russia, down into China, and over to the stands and then the women, and then through Europe. We can see it propagate around the whole world. But that's how it happens. That's how we're watching these earthquakes all the time. It's not new, but we're just bringing it to your attention. Hey, we're taking this one event and we're saying, okay, well, where did it come from? Where did that tension or that pressure or that Coulomb stress that popped it, made it pop? What was going on in the world? And we're trying to say that the whole system is worldwide and it's repetitive. Not like in the exact same spot, but close.
Yeah.
And so, like Southern Cal is always waiting for the big one, right? Well, there's some precursors.
Stuff has to happen before you get the big one.
Yeah. And it's not like any one place starts it.
Yeah.
But like we could be peering into the 1 year before, 1 year after, and only seeing those patterns. But you need a quadruple brain or a computer that can go a lot faster than we can, and they can go back 5 years, 10 years, 15, 20, 30, 40, 50, and see the pattern even persist even more. So it's like if I turn on the EMSC on the screen here, right? The EMSC, this is today's quakes, all right? So I'm going to go back in time. You watch the screen right up in here. See what you can see happen. I'm going to just go slow in time, right? What do you see going backward in time? Can you see something happening? And if I went forward in time? Are they related? This is only 1-2 days. We're doing years. We're trying to draw attention to you. Like central part of the U.S., I see a lot going on because that's what I was watching. But I saw a lot happen out here in Europe, the things I'm passing through. You know, these are the type of things that we're looking for. And this is why we do the rabbit hole, to kind of bring it across. All right. So we're up to the next one, buddy. Scholar, multi geophysical investigation of whatever.
Yeah. So this is a newer study on that same area of Long Valley. So it's
Okay.
interesting what it says. So we're just going to read it. It's not too long.
Okay.
Yeah. So I'll read it.
Okay. Go ahead.
The Long Valley region of eastern California is a natural laboratory for the study of the interaction between tectonics and volcanism. It sits at the boundary between the Sierra Nevada mountain range and the Basin Range extensional province, and is home to numerous volcanic features. The Hilton Creek Fault, a high relief normal fault, occupies a unique section of this boundary. At a left step in the range front, which due to crustal thinning is the site of large-scale volcanism in the form of the Long Valley caldera. Near the southern end of its trace, the Hilton Creek Fault exhibits over 1,000 meters of relief and accommodates the uplift of a large section of the Sierra Nevada. Crazy stuff.
That's
To the
crazy.
north, the fault projects into the Long Valley caldera, where it wanes rapidly as a series of minor on echelon splay faults with very little relief. In 1980, the region experienced several large magnitude 6 earthquakes, which resulted in ground cracks along the HCF, along the main trace outside of the caldera, as well as along the intra-caldera splays. As a result of the co-seismic cracking, the USGS Quaternary Fault and Fold database and the Uniform California Earthquake Rupture Forecast Fault Model both list the Hilton Creek Fault as projecting well into caldera and as having recently ruptured. The accuracy of this depiction has been questioned, with some researchers suggesting that the Hilton Creek Fault was beheaded by caldera formation, and that fault rupture modeling should not include the intracaldera components. We conducted this study to better document a subset of the intracaldera splays of the Hilton Creek Fault, to confirm or constrain their locations, and to quantify any vertical offsets which may be present. To this end, we conducted coordinated measurements of topography, total magnetic field, and very low frequency electromagnetic induction across a 1.5 square kilometer field area in the vicinity of Whitmer Hot Springs. Topography observations were collected using a total station at 317 points and an RTK GPS at 918 points. These measurements were later supplemented by a public domain high resolution DEM. Ground magnetic observations were collected using a backpack magnetometer across 22.4 linear kilometers. VLF measurements were along 6 profiles at 140 points using signals broadcast from Washington, Maine, and Australia. That's freaking crazy stuff. The VLF measurement suggested the presence of at least one saturated fault zone. The inferred
of VLF, VLF measurements were 140 points using signals broadcast from Washington, Maine, and Australia. VLF measurements suggested the presence of at least one saturated fault zone.
Yeah. The inferred fault was parallel.
Saturated.
Well, they could see it when they did all this.
Right.
The signal they sent from 3 points.
Right.
Australia. The inferred fault was parallel to a previously mapped fault trace, but slightly to the west. The VLF observations across other previously documented fault traces showed no variation in the signal. which would suggest the presence of a saturated fault zone. The magnetic data, both raw and processed, showed no clear evidence of faulting. Topographic measurements revealed numerous scarp-like formations with relief on the order of 1 to 2 meters, which generally correlate with previous observations. One of these scarps coincided with the fault trace interpreted from the VLF data. Overall, results confirm the presence of at least one strand of the HCF in the vicinity of Whitmore Hot Springs, which is saturated and likely acting as a path for fluid migration.
Fluid migration, everybody.
Yeah. The appearance of a saturated fault zone with measurable slip within the caldera suggests the intracaldera segment of the HCF is active and should be considered when modeling fault rupture scenarios. The results also demonstrate the usefulness of VLF in identifying fault planes in coordination with other geophysical methods, including high-resolution topographic analysis. So this one they did at the end of 2021.
Right. So
4 years
they
ago.
said there's a fault, there's a splay or something of the HCF through here. Now, the HCF is, again, the Hilton Creek fault zone or fault, right? A splay off of it or part of the fault. They said it's saturated. I'm wondering.
And it goes to Whitmore Hot Springs, wherever that is.
I think
So
that's
north of it.
I want to say that's in the north here. Share this tab instead. So we zoom in down. Boy, it's messy. Mammoth Lakes. Hilton Creek fault zones right through here. We don't know which part of it though. What's interesting to me is
but they're saying that it connects through to wherever Whitmore Hot Springs is. So wherever that is.
All right. So let's go ahead and look up on USGS. Share this tab instead. Whitmore Hot Springs, WHIT, more Hot Springs. All right, here we go. It's in the south. All right. So one connection comes to here. That's in the southern action. And here's the caldera in the southern part of the caldera. And based, looking at this map and that other one, the Hilton Creek comes in and just kind of splays to the left. It's a good thing it's welded shut. Do you know what I mean? A lot of this area is full of welded tufts. A welded tufts, like a crack in the ground came up or opened, and magma rose to the surface and then cooled, and thus welding it shut. It's a good thing that happened right there. Why? Because it was cracking the damn thing in half. Yeah. As you can see, it didn't make it all the way across, evidently, but it made inroads into it, because they said it from the articles that you just read. They're not associated with the magma chamber, but magma came in, did what it did, froze that thing. So we've got the Hilton Creek right here doing its thing. Over here, we have the 3.6s. That's Yosemite, right? It could have happened somewhere between here. I don't know where the exact earthquakes were. They talked about it, how it was in Mammoth. Mammoth just shook like, right? There's a mountain range between the two, or including the two. I immediately, when we're talking about welded tufts, I'm thinking of what's happening right now. Iceland is erupting again. Magma's down there. It's splitting the ground because the pressure is rising up. Gas is rising to the surface, melting the upper crust and splitting it right open. And magma's rising up and then goes all over the place. Now, I think I don't know if y'all were part of the show tonight. We talked about a little bit earlier how gases rise up from the surface, and in some cases, um, it just kind of just pours out, and then in other cases, it literally explodes out, and then empties itself, and then it collapses upon itself. I don't know if y'all were here part of that conversation, but that's kind of what happened here. And yet it's still active because there's still a hole there and there's still a connection. And now that this fault is found, and they don't know really how far it goes, where it goes. There's assumptions from one article, one group to another. There's some differences of opinions. But if you're splitting the caldera in half, and it's a good thing it welded itself shut, because if it didn't, what do you think about what would happen if the darn thing filled up again? If it started getting rise. Now, I don't know, but just north of it is a little place called Mono Lake. And I don't know if you got anything on Mono Lake yet, or do you?
Yeah, you'll see it the next one.
Okay. I'll hold off. I'm just going to continue with what he's saying. All right.
Yeah. So now we're jumping to 1986. So
1986. The Calfant Valley fault. All right. I'll read it. In 1986, the Calfant Valley Fault earthquake struck Mono County up near Bishop and Califant. Sounds too much like the whatever. You already know. I know. At 7:42 in Pacific Daylight Time on July 21, with a moment magnitude of 6.2 in 1986. 6 years later, everybody. And the mercantile intensity, or Cali intensity, mercantile. Yeah, because it's all about money, right? Yeah. In a 6 of strong. The shock injured 2 people and caused property damage estimated about $2.7 million. The significant foreshock and aftershock sequence that followed a few moderate events and was the last in a series of 3 earthquakes that affected Southern Cal and northern Owens Valley in 1986. Owens Valley, everybody. Strong motion stations in a Long Valley Dam. The instrumental building of Bishop captured the light to moderate readings from the event. The faulting reached the surface of the ground. The maximum amount of measurable slip was limited to about 11 centimeters or 4.3 inches of strike slip motion along the White Mountain Fault Zone. Other destructive and surface rupturing earthquakes, as well as long volume volcanic eruptions, have occurred in the area. Although the series of shocks occurred within the White Mountain seismic gap, the region continues to have potential for very large earthquakes. Go ahead. Do you want to read? You want me to continue reading or no?
I'm going to jump down to the tectonic setting part and go from there. I think. Yeah. The Owens Valley, located at the western boundary of the Basin and Range province, is confined by the Sierra Nevada mountain range to the west and the White Inyo Mountains to the east. The valley was brought about by active tectonics over the last 2 to 4 million years, and was the scene of a very large earthquake in 1872 that generated surface rupture from Lone Pine in the south to as far north as Big Pine, a distance of approximately 100 kilometers, 62 miles. Other large surface rupturing events in 1915, 1932, and 1954 delineate the eastern California, central Nevada seismic zone. As no large earthquake has occurred between the southern extent of the 1932 Cedar Mountains, Nevada earthquake's rupture, and the northern extent of the 1872 Lone Pine earthquake's rupture in the south, a distance of 130 kilometers, 81 miles. The zone has been labeled the White Mountain Seismic Gap. The 1934 magnitude 6.3 Excelsior Mountains earthquake and the 1986 Calfant Valley event were several smaller earthquakes that have occurred within the gap, and both generated limited surface faulting and some surface cracking in the volcanic tableland, which was created 7 million years ago from a major volcanic eruption that also formed the Long Valley caldera northwest of Bishop. An estimated 500 cubic kilometers of material tephra produced in the event covers the northern Owens Valley as a rocky landform. The surface of the layered plateau is known as Bishop Tuff and features fumarole mounds and hundreds of north-south oriented fault scarps, many of which are visible on topographic maps via aerial photography and satellite imagery. So, talking about what we just talked about.
Yeah. Well, the study I was doing earlier,
Yeah.
the earthquake, the super volcano that happened 18.8 million years ago. Okay. They said 500 cubic kilometers of tephra. Well, the one here in Arizona, 1,300 cubic. Wow. Almost 3 times that, right?
Yeah.
That's insane. But, and this valley was a huge boomer. I can't imagine.
And this was the same year as the Oceanside quake and the Palm Springs quake.
Right. I was reading that too.
Yeah. All in 86, which we talked about them before in a previous one, but we didn't talk about this one.
The first shots came in July 8, and M6 happened on Banning Fault near Palm Springs. The second event happened off the coast of Oceanside at 5.8. On July 13, while earthquake of Southern California coast occurred, an area thought capable of generating a tsunami. The earthquake near Palm Springs occurred on the portion of the San Andreas Fault system that had been designated a seismic gap and is likely location of a very large earthquake. Some seismic gap theories regarding potential future large earthquakes had also presented for the White Mountains near Calfant. So exactly similar things happening here in this area of Central California that happened in Southern California, or happened in Southern California. And it's the same type of, what do you call that? Sidestepping things that we've been talking about this whole series of studies, that these sidesteps can produce amazing power, but they can also reveal greater potential for that power to be let loose. Yeah. And I think that's should be, brought to mind when you see an earthquake happen on, let's say, on the San Jacinto Fault, and where did it come from? Well, it very well could have came across the gap on from the fault down here. Let me show you what I'm doing here. Oh, show you. Share this instead. Down here is Salton Sea. Right here is the Elsinore Fault. Here's the San Jacinto Fault. There's this gap, this jump over, this sidestep that we often see. And I don't know if there is, but I'm going to go to the USGS right now and share with you terrain so you can see. And I'll just do all day as one day. All right. Zooming in. All right. Here's the one fault. Here's the other fault. And then there's these earthquakes that kind of persist going from this fault over to this fault. All right. This is San Jacinto. This is them. We're talking about up here in the White Hills, right? And how they bounce over and all the way down into, where did it say? No, not this one. Oh, no, we're not doing 21 yet. We done that. This one. Where are we, bud? I got lost. Oh, right here. Saturated. All right. the fault in Long Valley. And we're talking about, share this tab instead. We're talking up here in Long Valley. The White Mountains are all these, and these are the Sierra Nevadas. And they're stepping across. Here's another step. Just so happens, I think right there. I think that's where the Chocolate Mountains were banging off. Is that where they're happening? Or were they happening down here? Go back to here, share this instead. Let me see if it's still going. I don't even know. Yeah, it's still going.
Yep.
Right here, Death Valley. Right. Close this. I'm going to show you 30 days. Look at this. That's one of those side steps. Here's the Owens Valley we just talking about. Here's a side step out there toward where? Nevada. Right? Here's Long Valley. This area here. Side step. Another side step out here into Nevada. So 1, 2, 3, 4. Look at this. Right? Swarm. If you want to call them swarms. Concentration of earthquakes in the last 30 days. We talked about up here in Orville, right there. Oh, this is Alomar. We haven't got there yet. But Orville. I don't want to burst his bubble yet. Here's Folsom Lake. Here's Orville Dam. Talked about this stuff. Ain't nothing happening in a month. Just a little bit here. On the outside, though, look at 30 days. Yeah, but yeah, I don't want to burst this bubble. So let's get back to it, buddy.
Yeah. Okay, so we're gonna find out where it came from.
All right. So what year?
86. List of earthquakes in 86.
I just opened to it.
So that was in May, the one we're.
All right. So you want to go back 85?
Yeah.
All right, going back to 85. And we're in May, so we'll just kind of read through it here. Oh, boy. Formatting again. All right. In January, 6.2 Argentina. Yeah. Yeah, Solomon. Yeah, it's going to be a little slower, but he says Central Chile had a 7.5. Central Chile is 7. Central Chile 6.7. Central Chile 6.6. There's an Italy one again. There's a minor damage Montserrat, Antigua, Barbuda, 6.8 in the Leeward Islands. That's the Caribbean, everybody. Yep. Remember that. Chile 6.6. Chile 6.6. April. Chile 7.5. Oof.
Chile's going nuts.
Chile's going nuts, baby. Watch out. May. South Sandwich Islands come in with a 6.5. June. Central Mid-Atlantic Ridge, a 6.6. Remember, Caribbean, Central Atlantic, adjacent each other. All right. July. Yes, I'm passing a lot because they're not on that area that we're watching. Okay. August, the western side, eastern side of the U.S. The Pacific Plate. There's a Central California in August, 5.9. Injuries in Avenel area, slight damage in the Hanford, Kettleman City, Lemoore felt in Coalinga, Huron, Latone, Burrell, Alpa, Wakena, Lost Hills, Creston, Goshen, Templeton, Reedley, California Valley. Yeah, there's a lot of what do you call them guys? 7-day Adventist people, maybe, or Mormons in these areas, because a lot of, you know, a lot of names of biblical cities.
Yeah.
So that happened in 5.9. That's in August. Is that the city? Is that one we were talking about? Yeah. Okay.
Nope,
Um,
we're
okay.
still 80.
Um, Northern Peru came in with a 6-1. Greece. There's going to be another one. There is. 8.1 Michoacan. Oh
Yeah,
my.
that's Mexico City quake.
Wow.
85.
Well, it shook Mexico City. Michoacan is west of it, but yeah. Um, Severe damage in Mexico City. And yeah, I remember that. I was, um, tons of cities just got wiped. 7.6 occurred right after that in Guerrero off the coast. All right. Michoacan is interior, central. Guerrero's on the coast. 7.6. So you have an 8 and now a 7.6, right? Yeah, 8.1 and a 7.6. Wow, 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 wow. And what did you have? Central, Mid Atlantic, right?
Yeah.
Yeah, yeah. Okay, you had the Caribbean? Yeah, yeah. Lots of stuff happening. Not just looking for
Chile.
Southern Cal, but we're watching, we're showing how all these they all relate. And get this, Northwest Territories of Canada popping with a 6.8. Yeah, baby. Alaska there comes after with a 6.3. Guatemala pots with a 4.5. These are all in October. Um, Mexico again, Michoacan comes back with a 5.4. After getting at 8.1, that's all they got with a 5.4. Wow. The Mid Indian Ridge on the other side, okay, came in with a 6.6. Oh my God, Vanuatu. Nicaragua comes in at a 6.1. Lots of damage. A lot of everybody felt that. El Salvador felt that. Everybody felt that. Everybody's worried about what happened in Mexico, and that was just devastating. Get this: a 6.6 happened where? In the Northwest Territories of Canada again.
Yeah.
Yeah.
There's a lot going on in 85.
So, and that's all it just did in 1985, everybody. 5 years after St. Helens, right? So now we're
Yep.
going to 86, and we'll check.
And we got to
Right?
get to May.
Got to get through May, and then we'll see. Okay. Remember what's happening. Mexico just went bango. The Caribbean went bango. The Central Mid-Atlantic went bango. Then Central America went bango. Then it moved down a little bit, right? Peru, 5.1. California came in with a 5.5. Hollister, Tres Pinos, Santa Ana Valley, east of Hollister. Damage Gorge, Cienega Winery, 8 miles south of Hollister. That's Monterey area. Tres Pinos, I believe. Let me just verify, just so. I believe it's right in here. I can just look at freaking frick.
His northern San Andreas section starts at Hollister.
Yeah. And Morgan Hill, Gilroy. I want to say it's right at the base of the Calaveras. Hollister's right here. 1989, right there. And so right there, and that just north of it is where the San Andreas broke in 1906. It's where it broke in 1895 or 96 we talked about?
65.
1892 was north of that on the other side. 1865. Also, the World Series earthquake just north of that. So this little section right here of the Calaveras Fault, ultra friggin' dangerous. Huge quakes happen. Many people die right there. Where's it? Monterey Bay, right here. Santa Cruz is right here, right? So the San Francisco earthquake that happened up here, share this tab, happened right up in here. They said everybody felt it up here, right? It burned down a city. That started down here and ripped all the way north, right?
Yeah.
So he's talking about Hollister. Hollister's right there. Right there. Okay. So back. All right. So
Back to 86.
yeah, 86. We're in 86 right here. 5.5 there. Ohio comes in with a 5. Remember what's happening? The Mid-Atlantic Ridge, Mexico City, or just west of Mexico City, the coast of Mexico, and down in Peru, the Windward Islands, the Caribbean, California, bang, right? I mean, Ohio, bang, in the central part of the U.S. Like I always, when the Atlantic goes off, I'm looking for something to happen in the greater part of the United States in the center somewhere, not on either coast. And I'm also looking on the coast, somewhere
It's
up.
basically the edge of North America adjusting on all sides.
So it's kind of like pushing through. February, Chiapas, Mexico, down south, up 4.7. Puerto Rico had a 4.7. There's Greece. March. All these are around Albania. Idaho comes in with a little 2. Bing. All right. It's not a big one. Don't know why. They call it Lucky Friday mine near Mullen. One person died. Collapse on them. Wasn't so lucky. Brazil, 6.3. California, 6 people were treated for minor jamborees caused in Fremont. Power outages occurred in parts of Fremont, San Jose, north of the other California quake, right?
Yeah.
5.7 here. Idaho was a smallie.
So that would be like Hayward Fault, probably.
Moving on up from those are Alaska there and 8. What the? Wait, that didn't happen yet. I went too far. 5.5 in Hollister, right at the base of the Calaveras Fault, right? And then later in a couple months, a 5.7 in Fremont, which is in the city of Alameda. Look at the East Bay region. That's on the other side. And making this 4th popular Bay Area behind San Jose, San Francisco, and Oakland. Okay. And moving on up where you all can see East Bay. Here's the Hayward Fault. And what was the city again? Fremont. I want to say it's on over here. 1868. I know they have it. 1861, 1980. Livermore. Castro Valley, San Lorenzo. Fremont's right here. Okay. Fremont's right here. Right? Oakland's just north. It's along the Hayward Fault Zone. All right? It moved from down here up along this fault and popped right there just a few months later. And some people would say they're not related. I beg to differ. I do. All right. So 3.7 Huntington Beach, Cali. Peru, Cusco, 5.2. Killed 16 people. Only a 5.2 killed 16 people. Wow. Alaska popped with a 6. Mexico, Michoacan. After that 8.1, he come back with a 7. Right?
Yeah.
Crazy. Next month, not a lot. Oh, Alaska 6.3. Alaska 8.0. Alaska. Largest event of 1986. Adak, Alaska. It's out there in the middle of the stuff. All right, all those little islands out in the middle. Adak comes back with a 6.4. Alaska again a 6.4. Alaska again 6.5. June.
And our Calfant Valley one was in May, too.
Calfant, did we talk about that? May?
Yeah, it was in May, but of course it's not on.
It's not on this list.
No, but it's 6.2. So that still makes sense with all the other stuff that was going on.
All right. And so in June, Valenzuela pop with a 6.3. Alaska again, 6.5, 6.8. The Kermitics started popping a bit. July. And nothing. Carlsberg Ridge. California, 6.0. North Palm Springs, 1986. $6 million damage. I felt this one. Yeah. And Tennessee comes in that same month with a 3.3. There's your interior one. Okay. There's another Ohio, 4.5. That's 2 Ohio quakes. Here comes another California, Newport Beach, San Diego. 1 injury damage, Newport Beach, San Diego. Area preliminary damage, $720,000. Neighboring Tijuana, Mexico. 5.5.
That's the ocean side.
It's offshore, oceanside quake. Okay.
Which we already talked about previously. That same year.
Alaska again, 6 and a 6. And then California pops again. Chalat Valley, what we just were talking about, 6.4. So Southern California bangs. Central California bangs. Northern California is already banging. All of California is banging. Why?
Yeah, because you had Palm Springs and Oceanside all going back to the Mexico quake in 85.
Yep. That down there, just off of Mexico. Not only that, but right in the middle, right? You've got up there in Alaska, Adak, Alaska banging. Then you got Mexico City banging, right? And you got the Caribbean plate banging, and so it's consistent.
Yeah. So
and next month, September comes through. Alaska another 6.5. Scotia Sea, 6.3. I think, isn't that over by you?
Scotia Sea is off the tip of South America.
Okay. South America. So that's over by Sandwich Islands.
Yeah, Scotia Sea is the
right,
sea.
Because there's a 6.1 right there, Sandwich Islands as well. Yeah. Alaska and a Sandwich. So it's like back and forth. Bing, 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 bing. Then there's the Carlsberg's Ridge again. Right? And then Sinaloa, Mexico, moving on up the coast. That's in the center part of Baja California on the Mexican side, Sinaloa, 6.0. October comes in. El Salvador pops with a 5.7 and a 4.5. What else?
And then if we went into 87, you get the Whittier quake, you get Superstition Hills and Elmore Ranch, which we talked about in a previous episode. So basically, after that 85 Mexico City quake, Cali was shaking for a while after that.
Yeah. Alaska still banging with this after it had its 8, still banging with a 6.8 in January. Colombia had a 6. East Pacific Rise comes in with a 6. Salvador with a 4. Sandwich Islands hit with a 7, all in January. And then they don't have any more in this. So,
Yeah. And like if you jump into 87, well, you're only like
I'm in 87. Yeah, they don't have any more.
Yeah.
So
you're only 2 years out from San Fran, Loma Prieta.
Right? Loma Prieta, right?
So you could consider like if you started going every year, you could see.
Well, Ecuador had a 7.2 in 1987. Argentina had a 7. Chile had a 7. The Sandwich Islands were popping it all with 7s. Alaska had a 7.9.
Yeah, the Gulf of Alaska. There was a big Gulf of Alaska quake in 88 too. And Yellowstone caught on fire. A whole bunch of wildfires in Yellowstone in summer 1988.
1988.
Yeah.
Yeah, Alaska had a 7.8 in the Gulf. Chile had a 7.2. Peru had a 7.1. Chile had a 7. All by magnitude here in those times. And then what I got? 1989. We have California with the 6.9.
Which was Loma Prieta.
Which is the Loma Prieta quake, yeah.
Which we talked about previously.
And then Alaska had a 7. And Brazil had a 7.1. But not felt.
So there's a crap load of stuff going on in the 80s.
So when Mexico goes big with 8s, look out.
Yeah.
You know, that's just insane. So, bing, ding, 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 ding.
Yeah, the next thing is a study that shows how they're all connected with the White Mountain.
Well, we're already 2 hours into this one. I think we should stop right there.
Yeah.
Because it will go on a little bit further. We'll add these to the whatever's left to the next one. Probably. Well, we can do. I don't know. Depends on how you feel tomorrow. You're going to go away on Saturday.
Yeah.
So you'll be spending the night over there. So I think Sunday you'll probably be wiped out. Yeah. Maybe we'll try to do it on Monday. Try to give a day. Because obviously these things are a lot. So I think 2 hours is enough for somebody to listen to. But anyway, so what we've talked about is how San Francisco or the greater San Francisco earthquake popped. Earthquakes have popped, what led up to them. And also that the interior part of North America or California, that there are still the same kind of patterns that persist with the same likely suspects around the planet on the around the eastern side of the Pacific plate, as well as the kicker over there in the Atlantic, and what happens along that mid-Atlantic ridge, and just how uncanny when something happens there, something happens over here. And it's really describing the movement of the plates in this series of studies that we kind of explain what's happening from the earthquakes, what's been going on up these things. No, we're not forecasting. No, we're not saying that this happens all the time. What we're saying is these places of interest pop. Do you know where? No, we can't for no, but we can see the pattern persist, and we can say these are likely areas that if a big quake happens here, I'm going to look to see where it could go. And the historical record shows time and time and time and time and time and time again that it does things. And, I know we kind of we're hyper focused on California only because we're working through the fault systems of California. If we worked at fault systems through Panama, we could see the same thing happen. If we work to the fault systems in Mexico, we can see the same thing happening. Nicaragua, Colombia, Costa Rica, uh, uh, a lesser portion up there in because it's less known, but in Canada and Alaska. And then if we decided to move up and over to the Kurils, Russia, Japan, Philippines, Taiwan, Indonesia, then if we felt really crazy, we go from Russia through China and over to Kazakhstan, and then all the stands, and then through the women, Georgia and all them, and then into Turkey, and then from Turkey through Greece, from Greece through Italy, and from Italy over to Spain, and then out to the Atlantic. And it's just kind of the flow that persists. And
because how this is going to work eventually, I'm actually teaching you about the lineaments by learning the faults first. That's what I'm doing.
mm-hmm.
That's really what I'm doing.
Yeah, the electromagnetic planet that we live on.
Yeah. And that's what they're using to identify these faults, like that newer study from 2021 I showed, that they were sending all these signals from magnetic and VLF and all this stuff, trying to figure out a fault that was in
the caldera. I'm trying to see if that fault even goes through there, and sure enough, they found parts of it in there through VLF.
And now they can see all these magnetic lineaments. That's what they call them now, with the new satellites since 2022. So they can see how this stuff is all connecting across large areas, because the satellite can see all this stuff that they're doing to identify where the fault is, because basically the lineaments and the faults are basically the same thing. One is just an identifier of the other, and it's all part of the magnetic system of how the Earth works and the planets and the solar system and everything else. So after, I don't know how many, like if we did just every state, you're going to see how it works. Because it's like crazy. And like Joe said, you could expand it out to other places. So you could focus on Costa Rica, or you could focus on the Caribbean, you could focus on Russia, you could focus on China, you could focus on whatever. And it's still all the same thing. You're just changing your reference point from how you're trying to figure out how it's getting to your spot. But it's all following.
There's a liquid flow of electricity, and we look for the inductions of that power through the sun, or whether through space, or whether through objects, or just the Earth doing itself.
Because everything's moving in space. Well, there's a reason why it's all moving.
Right. And it's kind of moving in a certain kind of look. Hey, well, if fishing is good, I'm down, he says. My boy's out there. All right. It's 45 minutes ago. I didn't want to call him because I thought maybe he'd be sleeping. That's my boy, though. Anyway, thanks, Canuck. You have anything else you want to close with? Or I think you just did, but
yeah, that's good for tonight.
Yeah, that's good for tonight. All right, we're uploaded 89 progress. All right, everybody. Thanks so much. Hang in there. Don't get nothing on you. And tomorrow is what? Steak Friday, bitches. Anyway, I get excited about Steak Friday. All right, love y'all. Don't get none on you.